In the world of Bitcoin, a key is a secret number that allows you to access and control your Bitcoins. Keys come in pairs, a private key and a public key. The private key is a secret number that only you know and must be kept safe, while the public key is a number that can be shared with anyone. Together, these keys form a pair that can be used to create a digital signature and secure transactions. In Bitcoin, a public key is generated from a private key through a process known as elliptic curve digital signature algorithm, ECSA. This process involves the use of an elliptic curve and a set of mathematical operations to create a unique public key from a private key. Once a public key is generated, it can be used to create a Bitcoin address. A Bitcoin address is a string of letters and numbers that represents a destination for a Bitcoin transaction. It is created by taking a hash of the public key and applying a set of rules and checks to ensure its validity. It's important to note that while a private key can be used to generate multiple public keys and addresses, each address is unique and can only be generated by a specific private key. In summary, keys and addresses are a fundamental aspect of the Bitcoin network. They allow for the creation of digital signatures and secure transactions, and are a crucial component of the decentralized and trustless nature of Bitcoin. In addition to understanding the technical side of key generation, it is also important to understand the concept of Bitcoin addresses. These addresses, often represented as a string of letters and numbers, are derived from public keys and are used as the destination for Bitcoin transactions. To ensure the integrity and accuracy of these addresses, a method known as base 58 and base 58 check encoding is used. This method adds a level of error checking and prevents common typing errors, such as mistyping a character or two. There are several different key formats used in the Bitcoin network, including Wallet Import Format, WIF. This format is used to import private keys into Bitcoin wallets. It is a base 58 encoded format that includes a version byte and a checksum. Mini Private Key Format. This format is used to generate a short, easy to remember private key for small amounts of Bitcoin. It is a base 58 encoded format that starts with the characters or K. Hexadecimal Format. This format is used to represent private keys in a more compact form. It is a 64-character string of letters and numbers. Base 64 Format. This format is used to represent private keys in a more secure form. It is a 64-character string of letters and numbers that is encoded with a secure hash algorithm, SHA-256. It's important to note that in order to secure your Bitcoins, you must keep your private key safe and protected, as it is the only way to access your Bitcoins. It is also important to understand that once a private key is lost, it is impossible to recover the Bitcoins associated with it. Additionally, each key format is used for different purposes and has its own unique properties such as level of security, ease of use and so on. It is important to understand these key formats and choose the right one that suits your needs and level of security. A private keys can be represented in a variety of formats. The most common format is the Wallet Import Format, WIF, which is a base 58 encoded format that includes a version byte and a checksum. This format is used to import and export private keys for backup and recovery purposes. Another format is the hexadecimal format, which is a 64-character string that represents a 256-bit integer. This format is used by command line tools and programming libraries to handle private keys. Additionally, the chapter also covers the mini private key format, which is a 22 or 30-character base 58 encoded string that is used for vanity address generation and paper wallets. In the Bitcoin protocol, keys are often encoded in a format called base 58 check. Base 58 check is a modified version of base 58, which is a binary-to-text encoding scheme used to represent large integers in a more compact and human-readable format. The base 58 check encoding format includes a prefix and a checksum. The prefix is used to identify the type of key, such as a private key or a public key. The checksum is used to ensure that the key has not been tampered with or corrupted during transmission. To decode a key from the base 58 check encoded format, you need to first remove the prefix and the checksum. Then, you can use a base 58 decoder to convert the remaining data back into its original binary format. It's important to note that in order to properly decode the key, you must know the correct prefix for the key type. Without the correct prefix, it is impossible to properly decode the key. A private key in the hex format is a 64-character string that consists of numbers 0 to 9 and letters AF. The base 58 check format is a modified version of the base 58 encoding format and is used for encoding Bitcoin addresses. To encode a private key from its hex format to the base 58 check format, the following steps are typically followed. The private key is first converted to binary form by translating each hexadecimal digit to 4 bits of binary data. A 4-byte prefix is added to the binary data, which is used to indicate the type of key and the network it is associated with. A double SHA-256 hash of the resulting binary data is calculated and the first 4 bytes of the hash are appended to the binary data. The binary data is then encoded using the base 58 encoding scheme, which uses a set of 58 characters that include the digits 0 to 9 and the letters A to Z and A to Z, with some characters omitted to avoid confusion. The final encoded key is then represented in the base 58 check format. There are 2 main public key formats in Bitcoin: uncompressed and compressed. An uncompressed public key is represented as a 65-byte value, with the first byte indicating the point's parity and the next 64 bytes representing the x and y coordinates of the point. A compressed public key is represented as a 33-byte value, with the first byte indicating the point's parity and the next 32 bytes representing the x coordinate of the point. The compressed public key format is used more frequently in Bitcoin transactions because it is more efficient in terms of storage and transmission. However, both formats are supported by the Bitcoin network and can be used interchangeably. In addition to these 2 main formats, there are also hybrid public key formats that combine elements of both uncompressed and compressed formats. These formats are used less frequently in Bitcoin transactions. It's important to note that, in Bitcoin, a public key is not the same as a Bitcoin address. A public key is used to generate a Bitcoin address, but the address itself is a hash of the public key, encoded in base 58 check format. One such advanced technique is the use of hierarchical deterministic (HD) wallets. HD wallets are able to generate a tree of key pairs from a single seed, allowing for a more organized and secure way of managing multiple keys and addresses. Another advanced technique is the use of multi-sig addresses. Multi-sig addresses require multiple signatures in order to spend the funds. This can be used for added security or for implementing shared control over funds. Pay-to-script hash (P2SH) addresses allow for even more complex spending conditions to be encoded into the address. This can be used for multi-sig addresses and other advanced use cases. Deterministic signatures are a technique that allows for the generation of a signature without revealing the private key. This can be used for added security in certain situations, such as hardware wallets. Stealth addresses are a technique that allows for the creation of one-time use addresses for added privacy. In addition to these advanced techniques, the reader will also learn about the different libraries and tools available for implementing these features in their Bitcoin applications. The BIP38 encryption process involves using a combination of a passphrase and a salt value to generate a derived key, which is then used to encrypt the private key. The resulting encrypted private key is a string of characters that can be decrypted using the same passphrase and salt value. One of the main benefits of BIP38 encryption is that it allows for the storage of private keys in a more secure manner, especially when stored on a computer or other device that may be vulnerable to theft or hacking. Additionally, BIP38 encryption can also be used in hardware wallets to provide added security for private keys stored on the device. It's important to note that BIP38 encryption is not the same as the encryption provided by a software wallet, as a software wallet's encryption is applied to the entire wallet file and not just the private keys. BIP38 encryption is applied to the private keys themselves and provides an additional layer of security. Pay-to-script hash (P2SH) addresses allow for more complex spending conditions to be encoded into the address. This can be used for multi-sig addresses and other advanced use cases. It works by creating a script that contains the conditions that must be met before funds can be spent, and then creating an address that is the hash of that script. The sender can then send funds to the P2SH address without knowing the specific conditions of the script, but the person spending the funds must provide the script and show that it is valid. Multi-sig addresses, or multi-signature addresses, are addresses that require multiple signatures in order to spend the funds. This can be used for added security or for implementing shared control over funds. For example, a multi-sig address may require 2 out of 3 signatures from a set of specified addresses in order to spend the funds. This can be useful for situations where multiple parties need to agree on a transaction, such as in a corporate or organizational setting. A multi-signature address is a type of Bitcoin address that requires multiple signature, or multiple private keys, in order to spend the funds. This is different from a regular Bitcoin address, which only requires one signature, or private key, to spend the funds. Multi-signature addresses are often used for added security or for implementing shared control over funds. For example, a multi-signature address could be set up so that it requires the signatures of multiple people in order for funds to be spent. This can be useful in situations such as a business setting where multiple people need to approve transactions. P2SH is a type of multi-signature address that allows for more complex spending conditions to be encoded into the address. This can be used for multi-sig addresses and other advanced use cases. The P2SH format is also more efficient in terms of storage and transmission than other multi-signature formats. A vanity address is a Bitcoin address that has been customized to include a specific pattern or string of characters. For example, a vanity address could be a Bitcoin address that starts with the letters BTC or ends with the number 1. Creating a vanity address typically involves using a process called brute force generation, where a computer program generates a large number of private keys and corresponding public keys until it finds one that meets the desired pattern. Vanity address generation can be a time-consuming and resource-intensive process, but it is possible to create vanity addresses using specialized software or services. It's important to note that vanity addresses do not offer any additional security or privacy benefits over regular Bitcoin addresses. They are primarily used for aesthetic or branding purposes. Additionally, it's also worth noting that the process of generating vanity addresses can be risky as it can leave your private keys exposed to others, if not done properly.